Hi guys, let's do this problem and I read the question first. Define the following as used in process control. Roman 1 control lag, Roman 2 process load, Roman 3 dead time, and Roman 4 control action. And so guys, we start off the question and this is how we are going to start off the question. Guys, before even we come to answer that question of control lag, here guys we have a graph and this graph has two components. First, it has what we call controller output. The C represent controller or represent output. And as you can see guys, I've given an example of an on and off controller output. That is whereby the controller will either switch off or switch on when guys we desire to have a desired response. That is from what we call controlled variable. And in this case, as you can see guys, when it is off, let's say guys we are heating some water, and so therefore the temperature of the water will begin to rise until it reaches a certain point. We call it SP, and this SP represents the set point or the desired output. And so guys, when we put it on at this point, it will take some time to respond. That means if you have a thermometer inside that water or thermometer measuring the temperature of the water, guys, we shall not notice any change for some time. And then after some time, guys, the temperature will begin to change and it will move until it comes now to the set point. And it will continue like that until this now controller may now come or put itself off, so that now to reduce the error. And so therefore guys, when we talk about the control lag, we are saying at the moment it begins to respond, guys, there is the time that will be taken for it to reach just before the set point, and that is 63% of its final value. And so therefore guys, that time taken from when it begins to respond, the temperature begins, or the thermometer begins to read a change in temperature up to this point, is what we are calling control lag. In other words, I read the statement: amount of time required for the process to reach 63.2% of its final value. Guys, now we go to the next, which we are calling, according to the notes here, we are calling process load. But before we go to that, guys, we have the control lag can also be said to, this indicates how quick is the process response once it starts to change. And that one can be indicated by, guys, as you can see, the gradient of this graph, meaning that if it has a steeper gradient, that is positive gradient, it will have taken just a little time. And if the gradient is low, is maybe not as steep as shown, it will take more time. That is, the control lag will be much bigger. And so guys, that is the control lag. Coming now to process load. Guys, as you know, in control systems, we usually have what we call the measured parameters. And guys, as you know, or maybe just to read the statement, it refers to the set of parameters excluding controlled variable that influence process when these parameters deviate from normal values. This is considered as change in process load that cause controlled variable to drift from set point, i.e. disturbance. Guys, what we are talking about is that all these processes takes place in a certain environment. Maybe guys, I can give an example of a vehicle that is moving. If guys, there is strong winds, maybe very strong winds, guys, you find that this is now going to cause the vehicle to deviate. That is, if it was moving in a certain maybe direction, guys, you find that the vehicle might deviate because of the strong winds. And that's what we are saying here. This is here we are saying excluding controlled variable that influence process when these parameters deviate from the normal values. That means that if there is something like floods and the vehicle is moving through the floods, guys, you find that the vehicle might actually deviate. Or if a vehicle is moving on a slippery road, guys, the vehicle will still have some, it will slip, meaning it will come out of its normal path. And then this is considered as change in process load. So whenever that happens, there is a change in process load. And this that causes controlled variable to drift. Guys, you can see the word drift, meaning that if we can even take a case whereby like maybe we can talk of a ship moving in water. That is, if it happens that there is some what we call waves, guys, the ship will drift from its set direction, and therefore this one is what we are now calling even the word disturbance. And this one comes about to affect the system in adverse manner. And this is what now, guys, we are calling the process load. So guys, that is the process load. And then we have the dead time. Guys, now going to the dead time, we go back to our graph here. As you can see, guys, here we have what we call the dead time. That is from this point to this point. Meaning that even when the controller comes on, guys, you will not notice any change in the controlled variable. That is, for example, if we are heating water and we put the gas on, guys, the temperature will not begin to change all of a sudden. It will take time, and that's what we are calling the dead time. And so, guys, as you can see here, we are saying this is how long it takes a process to begin responding to a change in control output. It's a period during which process does not respond to change in input. And in our case of heating water, we are saying the temperature remains as it was before the gas is put on. And so therefore, that is the dead time. Guys, now coming to control action. For the control action, it's the manner in which controller produces the control action by adjusting manipulated variable. This is where, guys, either we are maybe using a valve or even a switch, whereby the valve can be on and off, where when it exceeds the required flow, guys, it puts itself off, or when the flow is low, it puts itself on. Guys, we can also have what we call the proportional control. And other controls include derivative control. Guys, we have also integral control. And so therefore, this is the control action. That is the manner in which controller produces the control action. And so guys, thank you for listening to me. Bye.